Hello, good afternoon, everyone. So it's my pleasure to be here at the TAPA conference today, and thank you for the introduction. So in this talk, I'm going to talk about how we can apply adverse outcome pathways, a novel concept, to evaluate the health impacts of environmental chemicals. So this slide shows the overview of my presentation. At first, I will briefly touch upon the health effects associated with environmental chemicals. Then I will briefly touch upon the challenges in human studies in evaluating them. And then I will, and then I will touch upon how we can overcome these challenges using an integrated approach, followed by a case study related to this approach, and then finally touch upon the challenges and future directions. So, in our day-to-day life, we are exposed to a wide range of environmental pollutants and chemicals, such as air pollution, heavy metals, pesticides, and other chemicals such as PFAS and bisphenol A, through different routes of exposure, such as inhalation, through air and ingestion, through food and water, and then also skin exposure, which is associated with wide range of health effects, such as neurodegenerative diseases, respiratory diseases, such as lung cancer and asthma, cardiovascular diseases, liver diseases, and so on. So when it comes to the protection of public health against these chemicals, human epidemiological study and biomonitoring study are invaluable sources of information. So on one hand, epidemiological study investigate the association of exposure and related health effects through the direct or indirect measurements of biomarkers of effects. So biomarkers of effects or the changes, like biological changes or physiological or behavioral changes associated with exposure. But here, the limitation is these studies often provide low proof of causality, which means the mechanistic relationship between the exposure and health effects is poorly understood. Then on the other hand, it's a human biomonitoring study which provide information about internal dose and exposure biomarkers, which is changes associated with the exposure to a certain chemical and effect biomarkers, as I said before. But also here, there are some limitations. Often a human biomonitoring study focuses on non-specific biomarkers because their predictivity is unknown. And also often they are related to the changes that happens at the later stages of diseases. So these limitations offer challenges in protecting the public health. And that's where the concept, innovative concept, adverse outcome pathways comes in. An adverse outcome pathway is a conceptual framework which helps us organizing existing information in a sequential manner, as you can see here, and describe how a molecular effect leading to an adverse outcome in the population level. Simply, it consists of 3 blocks: molecular initiating event, which describes the initial interaction of a molecule, of a chemical with the biomolecule; then key events, which is like different biological responses at the cellular or tissue levels, which are measurable and essential for the progression of the molecular initiating event to an adverse outcome in the population level. So here are some examples of effects at different levels, but I will not go in detail here. So these are some potential applications of adverse outcome pathways. Adverse outcome pathways in general play a crucial role in advancing chemical risk assessments through the identification of biomarkers, development of assays to measure them, and also support the safe by design of chemicals. But today I will focus on this aspect, how AOPs can improve the understanding of exposure health association. So I'll go back to this slide. So how we can overcome the challenge that I talked about before. So this can be done by performing an integrated approach. So when epidemiological study integrated with AOP framework can lead to the improved mechanistic understanding and identification of biomarkers which is predictive and translatable to an adverse effect. And when we implement this biomarker identified in the epidemiological study, in human biomonitoring study, then we can detect the early changes at the molecular or cellular level, and also the threshold concentrations that is important for risk management and risk assessment and risk management. And this leads to an effective improvement in public health protection. So first, in this case study, I will talk about the developmental neurotoxicity associated with BPA, bisphenol A exposure. The aim here, as I said before, is to identify biomarkers of effect from epidemiological and toxicological study, and implement this in biomonitoring study and validate this biomarker. So the consortium members started with the systematic review of the toxicological and information, and also studies, information from human studies, and put them together within an AOP framework, and they developed an AOP network with the different molecular initiating events that leads to an adverse outcome, learning and memory impairment, which is associated with developmental neurotoxicity, which converges through a common key event. As you can see here, the reduced release of BDNF. BDNF play a crucial role in brain development. So here, this reduced release of BDNF can cover all the pathways that leads to the learning and memory impairments. So they identified this as a potential biomarker to implement in a biomonitoring study. Then, in a follow-up biomonitoring study, they measured bisphenol A urinary concentration in a birth cohort at the age of 9 to 11. Then they measured BDNF DNA methylation and BDNF levels in serum and urine, and then also they measured or they evaluated the thought problems associated with the exposure at the age of 15 and 17 years. So the outcome was the BPA exposure at the childhood was longitudinally associated with BDNF DNA methylation and thought problems at the adolescent age. So this study confirms that this BDNF DNA methylation is a physiologically valid biomarkers that could be implemented in the future biomonitoring study. And this is one of the few studies performed this approach. And then I will briefly show you another case study which I was involved. So the aim is to identify or evaluate the cardiotoxicity induced by environmental chemicals. So our partners, they started with the systematic review on exposure to toxic environmental chemicals and left ventricular dysfunction, which is a marker for heart failure. And then the outcome was the exposure to PM2.5 or PM10, arsenic or leads associated with cardiac remodeling, which is the geometric changes in the heart, which then leads to the left ventricular dysfunction. Then in parallel, me and my colleagues, we performed the systematic review on cardiotoxicity induced by environmental chemicals using in vitro and in vivo. Then we summarized and extracted information from all these studies. Then we put together this information into an AOP framework that is connected to the adverse outcome that we observed in the epidemiological study. So now we our consortium is developing a physiological model using cardiomyocytes, and they are trying to expose them to certain chemicals and identifying the biomarkers using multi-omics approaches that could be implemented in the future biomonitoring study. So here the take-home messages are: AOPs provide proof of causality for exposure health effects associations. They are shown to be a promising tool for the identification of early biomarkers in human studies that are predictive, translatable, sensitive, specific, and robust for regulatory purposes. And also they aid in refining safe exposure limits for environmental chemicals and offer better public health protection. And also they comes up with a lot of inherent challenges, which is our future directions. They have so far we have only limited AOP coverage because not all the underlying mechanisms leading to an adverse effect is covered. We also need to cover the health effects associated with chemical mixtures because current risk assessment is focusing on single chemicals. There's a need to identify low-dose, long-term exposure biomarkers of effects, and also QAOPs, which is a quantification of, or quantitative AOPs, which is very crucial for risk assessment, next generation risk assessment, but they are lacking now. And these challenges should be addressed in the future. And these are the wonderful people that I work with, and we have Maria and Alex here as well. And thank you for your attention.